I'm very sorry about the delay there. I'm delighted to be in a position to give this presentation at this stage of the N4 project. I suppose development of schemes of this nature, such as this N4 scheme in the northwest of Ireland, through planning, appraisal and onto construction, requires a huge amount of work, commitment, perseverance, diligence on behalf of everyone involved. And I would like to extend my gratitude to all concerned for their efforts in getting the project to this stage. For my presentation, I'm going to give you a brief background on the project, and we'll touch on the following headings: the project location, project description, its status, existing conditions, the project background, Phase 5 enabling and procurement, and the Phase 6 construction key stakeholders. So the proposed scheme constitutes the remaining portion of the N4 in County Sligo requiring improvement. The project should provide 14.7 kilometres of Type 2 dual carriageway between the existing dual carriageway at Collooney and the end of the Curlew bypass, as Rona said there earlier. This consists of 2.7 kilometres of the existing single carriageway being upgraded to a Type 2 dual carriageway from the N4 and 17 roundabout to Dorley, and 11.2 kilometres of offline Type 2 dual carriageway between Dorley and the proposed roundabout at Castlebaldwin. It also includes approximately 800 metres of offline Type 1 single carriageway to tie in with the existing N4 at the northern end of the Curlew bypass, as well as 4.5 kilometres of Type 3 single carriageway and 3.4 kilometres of offline combined footway cycleway from Collooney to Dorley townland, as well as approximately 700 metres of footway cycleway from in the Castlebaldwin area, linking the Miners Way to Castlebaldwin village. So that image just shows the actual scheme. So as you can see, it starts at the N4 and 17 roundabout. There is an online section for the first portion of approximately 2.7 kilometres. It then veers off to the west side of the existing N4. It crosses over the N4 at Ardloy and comes back in to meet with the existing N4 just to the south of Castlebaldwin. So this image here shows the roundabout at Tuberbride, the N17 coming in from the west side, the existing N4 dual carriageway coming in from the north. This is the existing N4, which will be upgraded to a Type 2 dual carriageway. And we have an east-west link, which was a link road going into the Tuberbride Business Park, which will now become a live public local road, which is referred to as the east-west link, which will provide a link over to a parallel road. So this is the continuation of the parallel road, which is the Eastern Parallel Link Road. It's currently live to the national road traffic at the moment. It ties in with the existing N4 just at the top of the photo there. There's an underbridge coming across at this location to link up with a roundabout, which serves as a link to the Western Parallel Link Road. And both of these parallel roads are required to serve the local landowners and the areas surrounding this, like Riverstown, Clunamahan, and surrounding townlands and hinterlands. This is the existing N4, which will be upgraded to a Type 2 dual carriageway. This photo was taken approximately in the beginning of November. So you can see construction is ongoing at the moment to get it across this underbridge. This photo here just shows an image of Castlebaldwin Junction. It's where the cross section shall change from a Type 2 dual carriageway to a single Type 1 single carriageway. So you have here Type 2 will be coming into the roundabout from the north. The type 1 single carriageway will tie in with the existing N4 around this location, which is the end of the Curlew bypass. We have a realigned local road here, which serves Highwood, Ballyrush area. This is a redundant local road, which will be left available for walkers and cyclists and will form part of the Miners' Way. This is a farm access road then running parallel to the main line to serve landowners. And we have a link back here on the west side, which will link back into Castlebaldwin village. So in terms of cross-section, the cross-section of the N4 and 17 from the N4 and 17 Tubberbride roundabout to the Castlebaldwin junction should be a type 2 dual carriageway, which has a capacity of 20,000 annual average daily traffic. The cross-section from the Castlebaldwin junction to the existing N4 tie-in, which is approximately 0.78 kilometers, shall be a type 1 single capacity of 11,600 annual average daily traffic. The type 2 shall consist of two 3.5 metre lanes in both directions, separated by a central median, which contains a double-sided barrier. There is also a hard strip of 1.5 metres and a hardened verge of 1.2 metres on each side of the carriageway. To allow for breakdowns, parking bays will be provided at intervals along the alignment. These parking bays shall be 20 metres in length by 3.5 metres in width, with 40 metre lead-in tapers and 25 metre lead-out tapers. These will be evident in the drone video, which will be shown by Sean later on in the presentation. So the project status, the project is currently at phase 6 and it's been developed in accordance with the TII project management guidelines, or Transport Infrastructure Ireland's project management guidelines. And these guidelines provide a framework for a phased approach to the management and delivery of national road projects. There are 8 phases, phase 0 to phase 7 at present. And as is mentioned, this project, I'm glad to say, is at phase 6 at the moment. So in terms of the existing conditions, I suppose I'm giving the presentation to the Northwest engineers. So, I gather that most of you probably know that this road is treacherous. It comprises a very substandard single carriageway road with significant variation in cross-section along its length. The carriageway width between Dorley and Castlebaldwin varies from 6.3 metres to 7.5 metres, with an average width of 1 metre. There are very restricted opportunities for safe overtaking, and there are 24 junctions with local roads, including the village of Castlebaldwin. There are approximately 70 houses with direct access onto the existing road. And I suppose more dangerous than that, there's approximately 160 field entrances serving land holdings along this stretch of road. So some of the key objectives of the route are to significantly improve the safety of the road, which has unfortunately seen over 30 fatalities in the last 40 years or so, which are evidenced by crosses that were erected some years back by an action committee. Another objective is to provide a corridor of transport infrastructure that will encourage and support investment and employment in Project Ireland's National Planning Framework, designated Regional Urban Centre of Sligo in the northwest. It's also an objective to improve journey time and journey time reliability, and to improve road-based transport, quality of life for residents, and improve accessibility and to work, education and other activities, and also to improve conditions for pedestrians and cyclists. In terms of the project background, planning and land acquisition, all statutory documents and preliminary designs for the proposed development were developed by the National Road Project Office of Sligo County Council and lodged with An Bord Pleanála in December 2013. Following a 3-day oral hearing in April 2014, the EIS and CPO were confirmed in July 2014 without any modification. Sligo County Council confirmed the scheme in August 2014 and following approval published the notice to treat and the notice to enter. The scheme required the compulsory purchase of almost 450 acres of land with over 135 landowners impacted. 124 of these land acquisition cases are now agreed, and a further 7 cases were vested as they were unregistered lands and no ownership was determined. There are now 4 outstanding cases to be agreed. In terms of advance works, following on board Pinola's confirmation of planning, Sligo County Council National Road Project Office continued to manage these. Possession was taken in Q2 2015 to enable advance works to commence, and all necessary advance works were prepared, tendered and managed directly by Sligo County Council's National Road Project Office and completed from 2015 to 2017. They included fencing and clearance, house demolition, archaeological testing, ground investigation, ESB 110 kV pylon and 220 kV pylon construction. The fencing and hedge clearance contract was completed in Q3 2016, and this included approximately 40 kilometres of timber post and rail fencing, approximately 290 agricultural gates, and all necessary tree and hedge removal works. So as part of the scheme, there were 16 houses required to be acquired from mainly most of them along the online section. 12 have now been demolished and 3 are now boarded up for resale post-construction, and we have 1 that we're awaiting vacation. In terms of archaeology, as you probably all are aware, Sligo is extremely rich in archaeological features. So advanced archaeological contracts were carried out on the CPO lands from Q3 2016 to Q1 2018. These contracts resulted in the discovery of 35 archaeological excavation areas, mainly ranging from prehistoric to early medieval period. 3 large-scale sites were discovered, 2 of which were highly significant archaeological sites, consisting of prehistoric, Bronze Age, Iron Age, ceremonial, burial and habitation complexes. And the 3rd was a large multi-period site with prehistoric burnt mounds and an extensive trackway system. 29 phylloxeras and 4 prehistoric habitation sites were also discovered. 2 large-scale previously unknown archaeological sites, which consist of an early medieval ring fort with south terrain and prehistoric palisade enclosure site, were preserved in situ. So, sorry, go back to that last screen there. That photo just shows a large double palisade enclosure between the townlands of Ardloy and Springfield. It's a significant site to be found on the scheme. And this image here is an aerial photo of a prehistoric palisade enclosure excavated in Carnegark townland. So as part of the advanced works, there were also ground investigation carried out, very detailed ground investigation. I won't go through the list, but you can see them there. It was very thorough, and this was led into the detailed design for the scheme. There was also a diversion required for the 110 kV power line in the townland of Tubberbride, which required construction of 2 angle masts and 2 pole sets. It was also necessary to construct a transmission tower in Clonlurg to achieve adequate clearance for the proposed road development under the Flagford-Stranraer 220 kV overhead line. So for phase 5, enabling and procurement, a tender process was undertaken to appoint consultants to assist in the progression of the remaining phase 5 works, in addition to provision of technical support to Sligo County Council for phase 6 and phase 7 of the TII project management guidelines. Halcor Barry, now Barry Transportation, were awarded the contract in Q2 2017. And the contract notice for the main construction contract was published on e-tenders and the OJ website, commencing the pre-qualification process for a construction contractor in Q4 2017. A contract notice for the main construction contract was published on e-tenders and the official journal of the European Union website, commencing the pre-qualification process in Q4 2017. Following assessment, 5 candidates were shortlisted and invited to tender in Q2 2018, and 3 consultation meetings were held. Tenders were received from 4 of the 5 candidates, and the 5th candidate withdrew from the competition. A detailed tender assessment was undertaken to determine the winning candidate. Sligo County Council then sought approval to award the contract in Q4 2018 and submitted a detailed business case to the Department of Transport. This was referred to the Department of Public Expenditure and Reform and on to the government, as the total scheme budget was projected to exceed €100 million. So the government then approved the funding for the scheme in January 2019. In terms of the phase 6 construction, Roadbridge were appointed the contract in January 2019 for a contract value of 80 million inclusive of VAT. The contract type used is a PWCF4, which is the public works contract for civil engineering works designed by the contractor. The construction commenced construction in March 2019. And taking the COVID closure period into account, the programmed road opening date is now Q3 2021. And finally, for me, to summarise the key stakeholders involved in the scheme, the sponsoring agency is Sligo County Council. The employer's representative is Barry Transportation Limited. The sanctioning authority is the government through the Department of Transport and Transport Infrastructure Ireland, and the main contractor is Roadbridge. Their design consultants, as Rowan has already outlined, are a conglomerate of Feely Timony, Clandillon, Burn Luby, and Ramball. So thank you for listening. I'm going to hand you over now to Brian Snow, who's the contracts manager for Roadbridge. Thank you.
Thanks, Bernard. Just making sure that's okay, Rowan, is it?
Yeah.
Yep, that's fine. Thanks.
Perfect. Good evening, everyone. I'd like to welcome you to tonight's webinar. In January 2019, Roadbridge were awarded this major infrastructure project in the west of Ireland, with works commencing in February 2019, the planned completion of Q3 2021. It involves the detailed design and construction of 13.6 kilometres of Type 2 dual carriageway and 0.8 kilometres of single carriageway. 1 compact grade separated junction, 8 kilometres of side roads, 3 kilometre Greenway, 4 overbridges, 8 underbridges, 2 roundabouts on the main line, 3 roundabouts on the local road network, 40 culverts, drainage utilities and accommodation works. A couple of photos there of the earthworks operations being carried out in summer of 2019. It's just an overview of our management resources required to deliver the project. Currently, we have 34 members of management on site and a design team of 12 staff based on and off site. So quite a large management team to deliver such a project. Labour and resources. At present, we have about 150 people on site, broken into direct labour, hired labour, subcontracts. During the peak summer months, we had over 265 people on site with over 100 items of plant. The plant varied from 80 to 5-ton excavators, dumpers, dozers, rollers, and graders. You will see from the high level numbers, which gives an indication of quantities of various materials in the project. In total, we had 1.8 million cubes of cut material, with almost 1.1 million of unsuitable generated from these cuts. 1.2 million cubes of fill material for road embankments. On-site testing of materials carried out to determine what was suitable for placement in embankments. A major challenge was managing disposal of the unsuitable material, all of which was disposed of on-site within the land made available, negating the need to haul off to off-site landfills. Environmentally, it was a huge benefit. Unsuitable material was placed in deposition areas and used for backfilling borrow pits where suitable class 2 or rock was generated. During the course of construction, we developed 2 on-site borrow pits where we blasted and processed 1C and 6F2. We'll point these out in the aerial footage, which we will play later on in the presentation. Drilling and blasting and crushing works were carried out by a specialist contractor, with pre-condition surveys carried out on all surrounding properties prior to blasting commencing, with a post-condition survey following completion of the works. Generally, all properties were surveyed within a 500-metre radius of the borrow pit. A detailed analysis was compiled after each blast report, following reports from the vibration monitors, which were set up at various locations. Earthworks mass haul, which would have been produced at project commencement to ensure the most efficient haul distance used for cutting and filling material. The screen is a snapshot of the mass haul on the N4 project. Poor ground conditions and weather proved a major challenge through the construction of the road embankments, with depths of peat ranging from 2 to 8 metres. And peak construction during the summer of 2020, we were hauling on average 100,000 cubes of material per week, which is quite significant. Bulk earthworks would generally run from April to September. The key, of course, to achieving these quantities is weather. Being in the west of Ireland to date has been one of the biggest challenges we've met. There are 12 number of structures on the project. The first 2.5 kilometres of the N4 south of the N4 N17 roundabout is online. Within this section of mainline structures 1 and 2 are located. Diversion of the N4 traffic onto the EPL was required to allow construction commence, and this diversion was open to N4 traffic on the 7th of September. I'll just touch on it later on. All other structures were accessible at project commencement. The design of local roads, local structures were offline and allowed for the local road to remain in place until the final tie-in was planned. A temporary closure was then ordered to complete the tie-in and divert road users onto the new alignment. We currently have 10 of the 12 structures complete and opened to the public. This is, for those of you familiar, this is structure 11 at Ardligh, which is the intersection between the existing N4 and the new N4. Structure was constructed without any road closures. The beam lift took place just less than a year ago, last December, and was carried out at night time. An all stop was in place during the placement of each beam, and we eventually ran traffic over, construction traffic over this bridge in February of 2020. This is just an aerial shot of Drumfin North, which opened to the public in August of this year. And I suppose a milestone from Roadbridge's point of view was the last beam to be lifted on the project. It was on structure 8 on the 13th of October. The last of 87 beams. Beams range from 10 to 27 metres in length and weighed 15 to 55 tonne. All beams were supplied by Banner Precast. Pavement, there's 12 different pavement designs applicable to mainline access road and local roads. Approximately 110,000 tonnes of asphalt, 75,000 tonnes of cement-bound granular material. Mainline was laid with a wide paver covering the carriageway width. Lag and Asphalt are a specialist pavement contractor who are appointed to deliver both CBGM and asphalt layers. Both materials were placed with the full width paver, which increased production, eliminates longitudinal joints, and is more efficient compared to standard paver. You'll just see the wide paver in use on the main lane base course back in September. Environmental surveys, I suppose. Roadbridge have a dedicated environmental officer on site since project commencement. Pre-construction ecological surveys conducted by Roadbridge's in-house ecologists before works commenced to inspect for active habitats, protected species, roosting potential, etc., as well as surveys for badgers, bats, otters, frogs. Identification surveys of all invasive species, all of which were removed and buried, and a tree number scheduled tree plants identified on site, which are giant hogweed, Japanese knotweed, and rhododendron. Specific management plan was developed, and a license for the removal and deep burial was obtained. Environmental surveys, walkover surveys of works during bird nesting season. Construction ecological surveys include walkover surveys, mentioned Q value annual surveys, including macroinvertebrate surveys of 11 number water courses to determine water quality using the Q value system. Survey results compared year on year to determine impact of construction works, be it negative or positive, on receiving water bodies. Camera surveillance to counteract the removal of a number of badger sets within the LMA. An artificial set was created at change to 11.8. This set is monitored with a trail camera to determine its success. Electrofishing of stream diversions following completion of stream river channels. Electrofishing completed on abandoned sections of the channel. Furthermore, environmental surveys, dust monitoring with 12 number dust monitoring stations throughout the project at cardinal points such as road crossings or close to nearest sensitive receptors. Groundwater monitoring surveys, there's 12 number ground monitoring locations and water level monitoring weekly and physiochemical testing quarterly. 11 surface water monitoring, 11 number water course on site. It was daily inspections, physiochemical testing monthly, drinking water monitoring, 4 number private well locations sampled and tested biannually, and pre and post radioactivity testing undertaken on drinking water reservoirs closest to blast locations. Noise, daily noise monitoring conducted at nearest sensitive receptors to works areas, and daily vibration monitoring conducted at nearest sensitive receptors to works areas. Continuous vibration monitoring conducted at Tubberscanavan House, which is a derelict structure listed under the National Inventory of Architectural Heritage. Blast vibration monitoring is undertaken within the blast radius and also at private properties within 1 kilometre of the blast. As mentioned earlier, weather has been a huge challenge in the project. Water management, specific plans developed with input from the construction team. Settlement ponds were constructed, a permit pump system in place, which is authorised and controlled by the environmental manager. We also have a dedicated environmental team on site. Dust management, we've reduced the site speed restrictions, dust suppression with water bowsers, and we've also 12 number dust monitoring stations. Noise and vibration monitoring undertaken at nearest sensitive receptors. Activities deemed to be noisy monitored closely, and if results obtained indicated levels were elevated. Mitigation in the form of noise barriers or screens were installed. Eco mitigation, artificial badger sets installed along with bat boxes. Preservation of an area within the LMA as habitat for the marsh fritillary, butterfly, and electrofishing of abandoned channels. Opening of the EPL, as I mentioned earlier, it is critical to get this open to work on the 2.5 kilometre online section of the main line, which included structures 1 and 2. You'll see at the top of the photo there the existing N4, the N4 roundabout, N4 N17 roundabout, and as Bernard mentioned earlier, the east-west link leading onto the east link, which will take you back towards Durley. It's a aerial photo looking north, roughly half change 1200. You can see drainage works, culverts, some widening works, and in the background, structure 1. a good view of the Greenway and the EPL, which is currently taking the N4 traffic. Again, a photo for same location looking south. The west link on the right hand side of the photo, with the east link taking the N4 traffic on the left and the main line under construction in the middle. This photo was taken back in September, so works have progressed since then. Structure 2 box culvert in the background. There's about 75,000 cubes of fill material required. That embankment is now complete, and we're progressing with drainage and substructure layers, with pavement to follow early next year. Roadbridge are a registered partner of Consider a Constructor scheme and agree to the code of practice in all our schemes. It is broke down into 5 categories: care about the appearance, respect the community, protect the environment, secure everyone's safety, and value the workforce. Attached is our performance chart from 2019, where we received an average score of 42.2 throughout all of our projects. And to date, we've received 4 gold, 3 silver, and 5 bronze awards, along with 9 innovations. Our high score was 47 out of 50 for the ONE wind farm in Mayo. I suppose, like all aspects of life, managing COVID-19 has been a big challenge during 2020. Following the reopening of construction sites, our approach to how we deliver works on site has changed significantly as a result. There are a number of guidelines and policies that now must be followed to prevent spreading of the disease. The CIF COVID-19 Standard Operating Procedure and the CIF Guide on Social Distancing. Roadbridge have also developed a suite of policies and procedures that are in place through all other sites. These include Standard Operating Procedure Management of COVID-19, COVID-19 preventative policies for offices and sites, and COVID-19 site-specific management plan. To date, the policies in place have worked really well and provide a safe workplace to all employees on site. And with the recent positive news on vaccines, hopefully we'll slowly get back to some bit of normality over the coming months. That's pretty much it from me. So I'd like to thank you, and I will now hand you over to our design lead, Sean Fitzsimons.
Thanks for that, Brian. I'm just going to put up my presentation here. As I said, thanks for that. My name is Sean Fitzsimons. I was design team lead for the N4. I'm just going to tell you a little bit about the design process. So as previously mentioned, the design team comprised of Fahey Timoney. Fahey Timoney were project director for the scheme. They also designed all the structures and carried out the environmental surveys and the associated environmental design. CCC, who I work for, as I mentioned, I was the project manager for the design team. We also carried out all the civil elements of the design, so the alignment, drainage, and all the ancillaries design. Ramboll designed the river structures, and Burnley carried out the geotechnical design. There's a couple of other consultants involved in the design team. So Atkins were the drainage and structures check, GDG carried out the Earthworks check, and CST were the road safety auditor for the scheme. So Bernard told you earlier on just a little bit about the tender process. Involved 3 consultation meetings prior to submission of consolidated outline proposals and subsequent tender submission. I won't go into too much detail, but I just wanted to point out some of the innovation we were able to bring to the design at the tender stage. So just on the left hand side there, you see what was the employer specimen design brought through EIS. And on the right hand side, the tender design ultimately developed. On the left hand side, we have a 13-meter embankment. On the right hand side, we were able to modify the alignment to bring that embankment down to 7 meters and significantly reduce the earthworks. In addition to reduction of the earthworks in that area, we were also able to just shift the alignment slightly to avoid the areas of porous ground, highlighted by the cursor there. And that meant that we were able to minimize the requirement for a piled embankment that was due to go in that area. So just on, sorry, this is just that element of design brought to life. So always nice to see your work come to life like that. Just this area here is the area where the 13-meter embankment was to go. Obviously, very significantly reduced, and hopefully an improvement for the scheme. Just on the detailed design, then I'm just going to talk you a little bit through the alignment design. The drainage design, pavement design, geotech design, and the structures design. So a significant focus on any of these schemes once you start the detailed design of the alignment. It's obviously first and foremost is to provide a safe alignment, but also you're going to look to optimize the earthworks. We were successful at the detailed design stage of bringing down increasing the suitable material that was generated from underneath the road. From road excavations by 176,000 meters cubed versus the tender design. And we also decreased the bulk fill by approximately 140,000 meters cubed versus the tender design. Overall, compared to the employer's specimen design, there was approximately 30% reduction in bulk earthworks, and the scheme was ultimately balanced through the use of on-site bar pits. Just some of the principal volumes, Brian ran through them earlier on, but obviously very significant. So there's approximately 1.5 million meters cubed of cut, including the soft material that needed to be excavated. 760,000 meters cubed of unsuitable material that was at tender stage, and before kind of some of the bad weather kicked in. So I'd imagine it went north of that. And just over 1.1 million meters cubed of embankment as well. So obviously very significant volumes, as Brian mentioned. This is just one of the bar pits. So I mentioned that the road itself traversed through quite soft ground typically, and there was very little rock and practically no rock, in fact, underneath the road alignment itself. So all the rock that was generated on the site was generated through bar pits. So just to give you a quick scale of the size of it, just a quick video there to show you some of the rock being excavated out of the bar pit. So don't know if you get a true appreciation of the scale of them, but you can also see supervisor standing at the top of that gives you an impression of the depth of these bar pits. Okay. Just on the alignment then, one of the other things that we sought to do, Bernard and Brian have mentioned the 3-kilometre eastern parallel link that runs adjacent the new N4 on the northern section of the scheme. So we propose to move the footpath that was shown here out to the fence line. So there's a before and an after shot there. Just move the footpath out to the fence line. So the benefit of that change was to increase the amenity and the safety for users of the Greenway, but also reduce the earthworks and the drainage works for Roadbridge. Got rid of this curb, and we were able to use sustainable SUD drainage systems. So that sort of proposal and others like it were progressed through variant conceptual design process. So we put together a technical note along with justification, some graphics. In this instance, we were able to refer to the standards which called for maintenance strips to be used, or cycle and pedestrian facilities provided in maintenance strip were required. And once we put that technical note together, we present that to Sligo County Council via barrier transportation. And in this instance, obviously, that proposal was accepted and incorporated into the scheme. So just on the drainage design then, so right from the outset of the scheme, we placed a fairly heavy emphasis on the use of SUD systems. The graphic shown in the presentation slide there is just an extract from the SUDS manual. So typically, we're all pretty good at controlling the runoff rate from these large developments. But SUDS systems are necessary in order to help you control the runoff volume, obviously increasing the paved area and reducing the impermeability of the ground. So it's also important that you consider the runoff volumes when you're developing the drainage design. One of the subsystems that we use, which might be of interest to people, is a line grass surface water channel. Typically a grass surface water channel is placed in the verge, collects surface water runoff and cut slope runoff. In some instances on this scheme, possibly maybe about 6 or 7 kilometers of it, we've used a line grass surface water channel. So the liner, an impermeable liner is added underneath the base of the channel, obviously to make the system impermeable. And you do that where you may otherwise have a groundwater vulnerability issue or to prevent the risk of karstification. So in order to use that detail, we had a departure granted. That departure was granted based on the contents of the environmental impact statement for the scheme, which called for the use of line grass channels. We also had contract requirements that required the use of subsystems throughout. The detail itself was developed bearing in mind past experience. So anecdotally, we had heard that this system wasn't favoured because of problems on past schemes. The problems that we heard, again, this is just anecdotal, but we had heard that the barrier had been punctured the liner on some schemes, that the liner hadn't been connected into the pavement. Possibly the details around the chambers hadn't been bottomed out. So they're all issues that we sought to solve to bring this proposal forward. It's just a couple of photos. So there was a trial section done. John Cran, I believe, won the subcontract for the works. So the channel was cut, liner installed, backfilled with clause 804. This channel being cut, liner installed here, backfilled and compacted. The line is then sealed to the pavement, and obviously it's important to get the details around the chambers correct as well. So still being finalised on site, but it looks pretty smart at the moment, and hopefully all going well. Kind of this is something that could be incorporated into future schemes. One of the other systems that we used then were linear attenuation systems. So what you see here are the linear attenuation system or linear wetland placed at the base of the embankment. So it typically collects runoff from pipe networks coming into it, but also collects runoff from surface water runoff from the road. So the attenuation systems themselves, or the linear swales or wetlands, they collect surface water runoff, they convey the water, and they treat and attenuate. So they're doing the job of what might otherwise require 3 systems. They do take up a bit of space, obviously, but we found that once we had reduced the embankment sizes, typically there was a bit of space left over in order to incorporate them into the scheme, and they were used quite extensively ultimately. They do have check dams along their length. So the check dams you can see here in the slide. The check dams are provided just to maximize the storage capacity, and they're particularly useful on steep ground. So you can see from the contours here, we're on quite a steep section, which is why we have quite a number of check dams. It's just to maximize the space within the system. And that's a typical section through the check dam there, based on a TII swale detail. Okay, a couple of photos of them coming to life here. So again, you can see them at the base, just at the base of the embankment. You can see the check dams being constructed. Obviously, a little bit of work to finalise these. But once they're done and landscaped, actually, we think that'll be a nice feature of the scheme. Okay, geotechnical design then. I think we've mentioned earlier that originally a tender there was due to be about 760,000 meters cubed of unsuitable material. Like I said, it's probably gone north of that given the poor weather. Largely peat, also marl and alluvium, and typically through 90% of the project there was a dig and replace methodology employed. So some people will probably be familiar with the typical details shown on the slide there. Effectively, you excavate all peat material and any soft material out until you reach a competent foundation, proof roll it, and then start backfilling. So if there's water present, you need to backfill with stone. Once you're out of the water, you can start backfilling with class 2 material. Okay, so mentioned 90% of the scheme, the other 10%, probably slightly less. A different solution was employed. So in just on the very southern tip of the scheme, vertical drains and surcharging was employed to deal with the soft ground. So first and foremost, all organic materials, all the peat was removed. At that stage, there was still marl and alluvium up to 10 meters deep. At the worst point, probably would have been more 6 or 7 meters, kind of would have been typical. And in order to deal with that, you effectively want to make sure that all the consolidation happens in that soft material prior to you placing any pavement materials. So a surcharge embankment was placed on top of the soft material, 2.5 meters high, and vertical drains were installed at 1 meter centers on a triangular grid. The initial design surcharge period was 7.5 months. That was ultimately brought down when the monitoring installed kind of showed that all the primary settlement had occurred. Instrumentation and monitoring was installed just as per the graphic on the slide here. Interestingly, landscape material also just had to be provided either side of the embankment, and we see that just as we go through the flyover. Now, one of the other elements of the scheme people might be interested in is the use of counterfeit drains. So a counterfeit drain is effectively just a drain installed in the slope that increases the stability of the slope by taking away any groundwater that's looking to percolate through the slope. So in this scheme, shallow and deep drains were both used. The requirements for the drains themselves were based on piezometer readings and also site observations. So typically the depths of the drains were limited. In order to limit them, berms were installed, and additional drainage was occasionally installed at the base of the cutting, just to ensure that the groundwater was drawn away from the cut slope. They're installed at 10 meter centers. A nice photo of one here of a few of them being installed. So you can see that they are quite significant in themselves. You can see the size of the cut slope by reference to the men standing beside it. But effectively, they're installed by cutting a trench through the cut slope, laying down a geotextile, backfilling the geotextile with the drainage dome, and connecting up the system to the drainage system at the base of the cutting. Okay, onto the pavement design. As Bernard and Brian were mentioning, there's approximately 3 kilometer section where we are following the line of the existing N4. Only 2.5 of that is so. Just at the end of that, we go over an overbridge. So obviously, we're grade separated from the existing N4 by 2.5 kilometers. Is online horizontally and vertically. We did quite a lot of playing around with the alignment just to try and get it as close to the existing alignment as we could, and thereafter sought to use an overlay design for that online section. So that started with scheduling a suite of testing. So the testing included falling weight deflectometer tests, cores were taken, ITSM testing and DCPs were done, and a visual assessment of the existing pavement was also done. So the condition assessment that followed included the visual assessment. So you're looking for any potholes, you're looking for any surface defects, any rutting. You carry out an assessment of all the cores taken. So you're looking for debonding, any problems with the cores. And you carry out a falling weight deflectometer assessment. So the falling weight deflectometer results give you an indication of the strength of the different layers of the existing pavement and the strength of the existing subgrade. And if all of those assessments pass the minimum criteria associated with for those in the standards, you can move on and carry out a residual life assessment. So we found typically that the condition assessment in all but one section, you can probably see the high FWDs there around change 2000. In all but one section, we found that the pavement passed the condition assessment, and we moved on to the residual life assessment. And typically, the results of the residual life assessment were that the pavement was in pretty good nick, and required minimal overlay. In fact, most of the sections that require any additional overlay. There's a couple of sections that required some strengthening. Ultimately, what we found is that you don't get to sit the new alignment exactly on the old alignment because of a change in crown line, because you're widening, change in horizontal geometry as well. And typically the pavement on the online section is dictated by the levels of the proposed design. Just to finish up then, I'll tell you a little bit about the structures on the scheme. So the guys have probably mentioned already, but there were 4 overbridges, 6 underbridges. There were 2 river bridges. It was originally to be a pile embankment, but that was ultimately designed out beside Tuan on the bridge, which I mentioned. There were 3 retaining walls, all ultimately designed out as well. There were environmental barriers, culverts and pantry bases. So the one of the overbridges and both river bridges were developed as earth retaining structures, and then the 3 remaining overbridges were 3-span structures, similar to the details shown there on the slide. So 1 principal span and 2 smaller spans, two smaller back spans. Okay, so just to show you some of the construction of the overbridges. You can see there the columns going up, column bases installed, and the abutment bases installed, with the abutments being constructed. We jump on a couple of months. You can see now the abutments are largely complete, waiting to be backfilled. The precast concrete beams have all been landed, and the in situ deck has been poured. So on the earth retaining structures, as I mentioned, there was 3 of them, 2 over the river over rivers that were 24-meter spans, and 1 over structure over the existing N4, structure 11 over the existing N4, which was a 19-meter span. So one of the interesting elements of the earth retaining structure, you can see here that the abutment bank seat sits directly on the retained earth. That's a little bit different from what has been done on other schemes in some instances, where the abutment bank seat would sit on columns that go down through the retained earth and have their own foundations. Okay, and here you can see the earth retaining structures being constructed. So this is structure 11. That's crossing the N4. Brian showed a picture of it earlier, but you've got the reinforced earth panels being constructed, straps at the back of the panels being put in place, and 6I6J material being backfilled onto the structure. Okay, and just to finish up then, there's just a shot of one of the box underpasses going in, all precast units delivered and assembled on site, and earth retaining ring walls. Okay, so that's the end of the presentation, and now hopefully I can share an overview with you, fly through. So hopefully you're able to see this. Somebody could just confirm.
Yep, that's grand, Sean.
Yeah.
This is just a fly through taken a couple of weeks ago from the south of the scheme heading north. And immediately you can see here, this is the area of vertical drains. So you can see where the landscape material was placed to hold in the embankment and subsequently taken away. So I think, Brian, that landscape, that surcharge embankment was left in place for 5 or 6 months in the end.
That's correct, Sean. Yeah, in place from March, and it was released in July, August, so it was of this year.
The last thing to be done before COVID rules kicked in, I think there was a rush on just to get that surcharge embankment in place prior to shutdown.
Correct, yeah.
Yeah. Castlebaldwin roundabout here. So as Bernard mentioned, this is the location where we move from single carriageway section into the type 2 dual carriageway section.
That side road has been opened as well for the last week and a half or so, so it allows us to dig out the plug in the main line of the existing road, which is ongoing at the moment.
The largest cutting on the scheme here. There's actually a surplus of materials down on this side of the job, so I don't recall that we did a huge amount with the alignment on this section. If anything, we were probably trying to raise it slightly through that cutting. Access track being constructed there at the top of, you can see the pre-earthworks drainage at the crest of the cutting. Just up on the left here, one of the larger borrow pits on the scheme. So obviously very significant rock excavation there. How long have you been at that excavation, Brian?
Since we returned from lockdown, so we're looking at late May, and backfilling operation has commenced. Actually, we've exhausted the material out of it, what our requirements were, and backfilling operation commenced last week. So the intention that hole will essentially be filled up to road level once complete.
See the settlement tanks here as well. So a pump is set up obviously down in that quarry, pumps it out to the settlement tanks, and the water runs through that prior to discharge. Always interesting to see how effective they are. Typically the water comes out quite clean. I did mention that we use subsystems. There are some concrete systems still on the scheme, typically provided to isolate any surface water runoff from outfall. So they'll be taken 50-60 meters away from the outfall, so that they're brought into the system, the attenuation and pollution control systems, to give them time to treat them. See the verges, I presume that's the verges being topsoiled there, is it?
That's correct, yeah. Progressing, I suppose. Passing bay on the right, yeah. 11 number laybys in the project throughout the length of it. On the right, you'll see a deposition area where soft peating material is stored within the landmates available. And on the left, another borrow pit where we won Class 2C material for building the road embankments. Again, another lay-by on the left-hand side.
So this section would have been quite visible for people travelling on the N4. See the cutting into the hill.
I suppose just to give you an indication of the topography of the ground, on the right-hand side we had a cut of 7 meters, and on the left-hand side maybe a cut of meter and a half. So quite significant side slope on that particular embankment itself. And on the right then is an access road that's currently under construction in off structure 12 there, which is just in front of us.
Just coming up to Tawn on the bridge here. So this is the area that I was mentioning earlier. Precast box structure, obviously, and this is the area where we reduced down the size of the embankment. So we were able to reverse the gradient, the longitudinal gradient of the road, which was rising in the specimen design. We were able to reverse it, so it was coming down towards the structure as opposed to rising out of this cut. Bring down the embankment and obviously get rid of that piled embankment that was due to be there. You can see drainage in the total slope in this location. Obviously these are all, so both verges have ducts all the way along as well. Ducts lined up there ready to be installed. It's the existing N4. So we were talking about this structure earlier, reinforced earth structure, obviously. Bank seats sitting directly on the reinforced earth. Brian was mentioning that the road was kept live, but no closures at all, was it?
So the beam lift was December of 2019. It was carried out over 2 nights, and there was an all stop in place for a period of the period it took to lift on each beam. So no road closure in place. It was all, traffic was maintained at all times. So it was a positive story.
Just off to the side there, you can see existing attenuation ponds. Those ponds are associated with the the existing N4, and this is Ardloy Lock. This whole area was one of the environmentally sensitive areas on the scheme. You can kind of see the extent of it almost from the colour of the colour of the ground. Kind of that sort of brown area is the wetland that was determined to be environmentally sensitive. A number of design and construction requirements associated with protection of that area, and you can see the scheme. You can even see the colour differentiation between one side and the other. The scheme just kind of skirted around the edge of it. Just up on the left here is one of the, so we're just passing over Kingsbrook Underbridge, and one on the left here is one of the swales linear wetland systems that's being installed. Kind of probably reaching nearing completion.
Just coming up to the second of the borrow pits where we would have extracted rock on the right hand side. This is a backfilled borrow pit. Again, generated a large volume of material out of it and disposed of the unsuitable material that wasn't suitable for building earthworks embankments into this area. So that's now complete. And the borrow pit.
That's the borrow pit that was shown on my presentation, a short video there. It's incredible to see. You wouldn't believe there's enough material on the job to fill it in, and you find you wouldn't be long filling it. And what further swales there on the left hand side of the scheme, so those ones particularly looking particularly well. On the right hand side there, lay-by
topside embankments.
I think one of the things that I do see kind of as I go through the Flythrough is just how much every scrap of land was utilised as deposition. So you can see there's a large deposition area here as well. And just kind of building up, very well finished, I have to say. So this embankment, Brian, would have been constructed on sloping ground, as you mentioned earlier. So, like, you know, very significant slope there, which if I recall, kind of does slow down the earthworks operations to some extent, having to bench it in.
It does, yeah, and you're generating. I suppose we're just coming out of a cut into a wet area as we approach structure rate. So challenging at the best of times, the depth of excavate and replace and the topography of the ground.
This is one of the wetlands here that takes pipe network drainage as well as the surface water runoff. You see it comes down and then turns back on itself just to get that extra bit of storage space, widens out as it turns back on itself. Just coming up to the first of the two river bridges now. So this is structure 8, Drumflin River, 24 metre span, I believe. Earth retained structure, as I mentioned. Obviously, there was a temporary haul road Bailey Bridge installed prior to allow traffic get over the river in the temporary scenario. This whole area is prone to flooding, so you can see just how far the flooding extends. So obviously a flood study was done for the road to ensure that it was sufficiently far above the flood level. Embankments are built with stone below flood level. Actually, even this access track is above the flood level. That would be typical of access tracks, but the access track itself acts as flood protection in this instance. Just coming up to Drumfin, Cluenberg here. So this is the only grade separated junction on the scheme. 2 roundabouts, 1 grade separated junction. Compact grade separated junction, I should say. So it's just a T junction at the top onto the local road. Get the kind of Roadbridge mini compound here, but you can see the scale of these deposition areas that would have been more or less at grade. It's also where the linear wetlands come into their own. Provision of the linear systems, where you do have space, handed back an awful lot of this area that would have otherwise been used up for attenuation ponds. Very neat finish up here as well. What is it to say? Some of these excavator drives, they could brush your hair with the bucket.
What they say, Sean?
They could brush your hair with it. The mainline pavement is flexible composite pavement, so CBGM, and it'll have a SMA surface, so it's a low noise surface. Okay, just the size, the extent of the deposition area. This section of road would have been in a small section of embankment had it not been for the deposition area. And you can see that the deposition area comes up almost to the soffit of the overbridge. Again, that side road would have been on 4 or 5 meters of embankment. Is actually in cut. The deposition area is so extensive. This is another area where you have a linear attenuation system. You can see that the double height, effectively deposition area there, 4 or 5 meters high. Probably jump on here a little bit and keep us on track. Just coming up to the second river bridge here, the Turnaliden stream, structure 5, wetlands coming down towards the stream. Similar construction to structure 8, similar span, reinforced earth structure.
Just a question came in there, Sean, about burrow pits. Are they all within the LMA? So I presume you can answer that, Sean, yourself, but they are all within the LMA anyway.
Yeah, everything is within the LMA. All burrow pits and all Site 1 material was generated from within the LMA.
The CBGM, Brian, I believe, was delivered, so it wasn't. With some of the larger schemes, you'd see the CBGM being produced on site with on-site batching plants as well. But we didn't have very significant quantities of rock on this scheme, and
yeah, and I suppose it was generated from local burrow pit in Balsadare, so structure.
structure 4 we just passed over, so one of the overbridges. The 3-span structure. You'd see some of the motorway structures are 2-span structures. 3-span, if I recall, was dictated part of the works requirements. 1 large span and 2 smaller back spans. Okay, deposition area just there on the left.
Hey, Sean, one of the questions that came up on the chat there might be worth just mentioning now as well is the safety barrier, the median safety barrier. Any comments on what's going in? Obviously, you don't see it there at the moment.
Yeah, double-sided steel safety barrier. So again, on the motorway schemes, you'd typically have a concrete median, or you would have in years gone past. So this is a Type 2 dual carriageway double-sided steel.
Okay, thanks.
the narrower cross section, you don't have drainage in the central median. So when you are super elevated, water does go from one side to the other. I did actually have slides in the presentation just about designing for transitions and checking for water film depth, but cut them short because we're already 20 minutes over time here. So apologies for anybody who's waiting for their dinner. We're just coming past the tie-in into the N4 here. So this is the eastern parallel link that you see the traffic driving on there. As I mentioned, so this section, the Greenway is effectively as per specimen design, and then we've taken it off. Probably a fair bit nicer for users to be just a little bit separated from that bit further away from the traffic at the early junction there. Ryan, when did you start the works on that underpass? I was in, for those familiar, those driving by, they've probably seen it happen, but for those not familiar, it's a case of get the traffic off the N4 and start those works.
Yeah, I suppose this works has well progressed since this drone footage was taken. The HAC traffic, which is currently cutting across our spread, 500 meters north of this point, will be directed back underneath structure 2. It'll be after, but hopefully in January at some stage. I will allow us close this plug here in the center of the footage where the traffic is currently crossing. And similar with structure 1, at the moment we're facilitating traffic on the existing road, and the intention will be to divert traffic over the structure in the early part of 2021.
Bernard went through this obviously, but this line here is the western parallel link. Eastern parallel link which is what traffic is traveling on at the moment. All the N4 traffic is traveling on the eastern parallel link. And you can see the old road obviously is now being closed. Close to traffic and works commencing. So we're just coming up here, and just further up here we can see where the existing pavement's going to be widened. So obviously box dig out for the widened pavement. Test the subgrade, place your capping, test the capping, place your clause 804 material, your subbase material. So I mentioned in the presentation that the online section is we're going to utilize an overlay design, and just beside it it'll be flexible pavement construction.
Just on that area there with Tubberscannon and Lock on the west side, and a number of houses on these side, this particular area was very tight to get a design in the planning stage. So it's you can see everything merges together at this location really.
Yeah, comes in very tight. The LMA comes in tight as well. One of the few attenuation ponds left in the scheme. So I think there's three developed fully as attenuation ponds, with all the rest of the scheme using linear wetlands.
So the cycleway is 3.4 kilometres. I just see a question came in on that there from Tubber right up to Dorney.
You can see it rising up with the existing ground here, so you're kind of over the EPL here. The berm constructed in there just for the safety of users. Just on the online section, you can see all the works going on there at the moment. So that's all. This is all the widening. The alignment was amended during the tender and detail design to keep all the widening to one side insofar as possible. So the outer verge here, effectively the position of the verge gets to stay the same, and all the widenings on one side. So all the ducting works going on at the moment, drainage works going on at the moment. Again, this is structure 1, Brian. Again, you wouldn't have started that all that long ago.
Yeah, again, works are progressing at the moment. Early 2021, the intention is to run the local traffic over the structure onto the EPL to allow the remainder of mainline works be completed in this area and back towards the N4 and 17 roundabout on top of right.
Large borrow pit there, so those familiar with driving the scheme would have seen the hoarding just up in this section that was present while that borrow pit was excavated. Another location where rock was sourced, all backfilled now. Obviously the existing N4, N17 Collooney roundabout here, so the N17 is just down there. This is the east-west link that Bernard pointed out earlier on. Tuberide East Junction and Roadbridge's compound and their famous canteen just in here. That's it. Okay, I'll hand you back over.
Yeah, very good. Sean, Brian, Bernard, thank you very much for that. Great presentation. Gives us all a great feel for what's involved in delivering such a large scale road scheme. After watching that aerial tour of the site, I feel like I've actually seen the whole thing myself. So it's not a bad substitute for the real thing. I suppose it's one of those iconic projects that we'll all be benefiting from in the region for generations to come. I think Bernard Mulhern has a comment up there. It's the gateway to the northwest, which it really is, and it's another key piece as well of the upgrade to Ireland's strategic national road network. So, folks, I think we might just open it up to some questions. We have a number typed in already. We have a number of questions typed in there, and so just a reminder just to put them into the Q&A and not into the chat if you don't mind. So I'll just read out a few there, start us off. One question there just was overnight parking of HGVs considered, just in terms of the laybys. I presume that's an operational issue really for TAI. I know it's obviously there aren't any motorway service areas necessarily on this scheme, but maybe Bernard might have a comment on that.
Well, I suppose we certainly we didn't consider overnight parking for HGVs. It's not a requirement of TII standard. I presume the parking bays could accommodate HGVs. I'm not sure if that would be ideal, to be honest. I'm not sure that that's what they're really intended for. I suppose there is Collooney Village is to the north side of the scheme, and Castlebaldwin is to the south. So ideally, if there were parking, would be ideally off the type 2 dual carriageway.
Yeah. Okay. Question here from Owen Kilroy, just in relation to, was the release of carbon dioxide associated with the peat earthworks considered as part of the EIA? Again, Bernard, you might have a comment on that potentially.
Sorry, the bulk earthworks, is this?
Yeah, just in terms of, I suppose, it was greenhouse gas carbon dioxide emissions. I don't know if that was considered as part of the EIA, I presume.
I don't recall it being considered. Sorry, under the air and noise, the air chapter, it possibly was considered. I just can't recall the exact details of it, to be honest, Rowan, with you.
I would say that as part of the detailed design, that's something we were quite conscious of. I mean, obviously, you can say that it suits Roadbridge to reduce the excavation of soft material, but I think it was something, we were quite conscious as a design team to see if we could minimize the footprint of the road where it goes through bog and soft material. And part of that was, looking at, considering the carbon footprint associated with the excavation of peat in particular. So we carried out, alignment optimizations and the earthworks optimizations kind of with that in mind, and obviously with the cost savings in mind as well, and ultimately reducing the amount that would have to be disposed.
Okay, thanks. Question from Adrian Gildee, basically complimenting you on your presentation. A question for Bernard, may also be for Sean, just in relation to, we mentioned a 30% reduction in bulk volumes between the specimen and the actual design. What are you putting that down to?
I suppose there's an implied criticism in that, but that's not the way I would have seen it at all, and it's something I spoke about during the consultation meeting. The Sligo County Council team, or the NRDO, who would have developed the original scheme, it's their job to make sure that there's sufficient land available for the project, and it's our job as a design organisation to make sure that, and in conjunction with Roadbridge, to make sure that the earthworks are minimised insofar as possible. And you can see from the fly-through there that every scrap of land was used.
Yeah, I suppose that,
we worked quite hard to minimise the earthworks, but it's a different role that we had than what the NRDO would have.
At design stage, I suppose, you do take a very conservative approach in terms of this. So you design to your absolute best criteria that you can achieve. And obviously with design build, the motive is to try and reduce cuts and fills and reduce the cost to the contractor. So I suppose that's essentially why that is now. Obviously, Sean has said 30% is probably less than that, really, in reality, isn't it? That's how.
Yeah,
maybe,
it would be. Yeah, it's certainly less than 30%. I wouldn't have the exact figures, but certainly less than 30%.
And I would say that some of the things we did with the drainage design in particular, so we added a couple of outfalls that allowed us to place low points in between structures that wouldn't have been there otherwise. And obviously I mentioned the use of the linear wetland systems. Kind of with the new outfalls, there was no space for an attenuation pond, which is why, in some instances we would have used the linear attenuation systems. And as I mentioned, kind of the reduction in the earthworks generated that space. So that was a slightly different approach, let's say, that we've taken as specimen design.
Okay. You mentioned drainage there, Sean. I think there's one for you here. Just any comment on the maintenance requirements for the linear attenuation systems?
Well, they're not so dissimilar to ponds and ditches. We were slightly conscious of the potential for the outlet pipes at the berms to be blocked, and they were sized accordingly. Then, bearing in mind the potential for them to block, we also have a little sump in front of them in each instance as well. But the swales are, they're to a swale detail, so that we'd expect the maintenance program to be similar to that associated with swales, which are a typical TII detail.
Yep. Okay. Thank you. I think Bernard, you answered the one in relation to the length of the Greenway. Obviously, major project, but you're also developing the first section of Greenway in County Sligo.
Yeah, so it's 3.4 kilometres long from Tubberbride to Dorley. We're also including a little section from the Ballyrush Road into Castlebaldwin, which is approximately 800 metres, and that will form a link between the Miners Way and Castlebaldwin village.
Yeah, and I believe it's already very popular.
It is indeed, yeah.
Yeah. Just a message of congratulations here from former colleague Gary Salter in the Sligo County Council, who remembers the proposals being developed back in the 1980s. Question there just in relation to any, I suppose, have you learned anything in terms of lessons learned in terms of dealing with landowners through design and construction? Any lessons learned?
Well, in terms of landowners, we worked, I suppose, in conjunction with the landowners for the scheme. By and large, most landowners eventually came around to the idea and felt the scheme was a great benefit to the local area. We had an action committee most of whom were actually landowners who were fighting for the funding for the scheme. And I see Bernard Mulhern tuning in there. He was involved in that action committee as well. So lessons learned. I suppose the online section required demolition of a lot of houses. In our case, we didn't have an option of avoiding an online widening a section, but I suppose it's just something to bear in mind for future projects. It's not all, it doesn't have all the benefits you might think carrying out widening of an existing network. Sometimes it's better to go offline. Okay. If at all possible.
Yeah. Sean, I think you mentioned anyway, karst, obviously it is, you did encounter it, obviously, obviously it brings a lot of complications. Any comment on the karst features you encountered?
Yeah, so the scheme did progress. It was true in areas identified as high to extreme karst risk. And there was a karst risk protocol in place. I actually had a couple of slides in my presentation about it at one point, but they hit the editing room floor as well, I'm afraid. It probably wasn't the most interesting scheme ultimately from a karst point of view. The M17 and 18 progressed recently. It was very interesting from a karst point of view, and we would have used a similar protocol in this scheme.
Yep.
But ultimately, I don't remember seeing any karst features, Brian. I don't know if
none on the project, Sean. No.
Yeah. Okay,
they were assessed, but they were none discovered.
Yeah. Okay. Just a question here from Michael Bassett again. How did you deal with flood zone replacement when the new construction was placed within flood zones? I don't know if we are in flood zones, but
yeah, I think there was effectively a flood study done. I mean, this would have been done at EIS stage, but flood study was done and the impact of the scheme assessed. There weren't any flood compensation areas provided, but then the scheme passes over the John Finn River and goes through the floodplain, all right. But I don't believe any floodplain compensation areas were deemed to be required.
Yeah. David is just asking about that acronym there, ITSM, just in relation to pavement tensile testing. I don't
dismiss that one.
Yeah.
I thought I was doing well with FWD and
right.
getting out what that stood for.
Yeah, well, I think it's just testing the, I suppose, the tensile strength of the pavement, but that's 100%. Bar pits, I think you mentioned that, are the bar pits in council-owned land and farmers' fields, so that was all within the LMA. Yeah. Let me see, what's the saving in journey time, Bernard? Would you know off the top of your head?
It's a tough one from Val now, but I'm afraid I don't know that off the top of my head, but I can go back to Val on that.
Yeah.
I would guess it's not necessarily that significant.
It's not
traffic dependent.
Yeah, no, it's not. I suppose safety and reduction in fatalities what was the key benefits that were attributed to this scheme.
Okay.
Really
Alan Mulryan there has just a question in relation to the idea behind the hardened verge shown in the Type 2 dual cross section in Byrne's presentation.
Well, it's just there to provide a place for people to pull in if it's an emergency situation. I presume you have to get a puncture or something like that they can't make it to the parking area.
Yeah. Okay. What is your strategy to taper traffic from dual to single carriage? Well, obviously that's happening at roundabout junctions, effectively, isn't it?
Yeah, I suppose that's the reason the roundabout was included at Castlebaldwin, by and large, to change the cross section from a Type 2 dual carriageway to a single carriageway.
Yeah. Shane Cosgrove has a question there. Was there any soil stabilisation or geotechnical support necessary for the deposition areas, especially where they were above the new road? And also, what approach was taken to compaction of the backfill of the borough pits?
Yeah, I suppose there would have been a geotechnical design compiled to retain the peaty material. That bund would essentially be built around the perimeter of these deposition areas, and the softer or unsuitable material then was contained within that berm, we'll say.
Just in respect to the stabilisation, there was lime stabilisation carried out on the project to improve the suitability of the marginal material at one point.
Okay.
On the road embankment, yeah.
On the road embankment, yeah.
Kieran Riley, congratulations on a good presentation. Asking Sean, what were the overall scheme benefits of switching to the linear drainage?
I suppose there was a few of them. The first one, as I mentioned, is we found that in order to introduce low points and reduce the earthworks, you needed to provide attenuation systems that mightn't have been envisaged in earlier phases of the design. So first off, it helped us to reduce and balance the earthworks. The second thing is, you got to use a place that was going to be used for drainage anyway. So you'd have drainage at the base of those embankments anyway. And by widening them out, you got to provide your attenuation systems within those systems that were going to be provided anyway, and hand back some space to the contractor to use as deposition areas. So ultimately, that provided, reduced down the haulage associated with having to store unsuitable material. I don't know, Brian, there's a bit of work involved in them as well, and they take up, they have a significant area. So
yeah, they do, certainly do, but look, you can see the benefits in it. I suppose you can see it's progressing well based on the footage that we've seen. So
yeah,
I would say that the biggest benefit to the scheme was that it allowed us to reduce earthworks in areas that we wouldn't have otherwise been able to reduce earthworks if we weren't able to use linear systems. But obviously, where you're using that linear system, you're replacing potentially a concrete surface water channel, a carrier drain system, and an attenuation pond, and potentially other treatment elements. So it's that one system doing the job of all three, plus it helped us reduce the earthworks. And kind of it provides a kind of additional area associated with biodiversity, once they're planted.
Yeah, very good. Quick question there. What is the depth of the cement-bound granular material typically used?
It's 150 on this project.
150. Okay.
Yeah.
That's fine. John Owens there just asking a question just in terms of cost benefit ratio. I think this probably goes back again to the planning stage. Bernard, I don't know if you have any comments on that.
Yeah, so I suppose we would have been aiming to get over 1. That's the general requirement. I don't understand the second part. Is there an element of tariff cost?
Yeah.
I'm not sure what that
okay.
means, to be honest
Okay.
with you.
Okay. Okay. I'm just going to keep moving here because I'm just conscious of time, if that's okay. Fergal McLaughlin, excellent presentation. Is there scope for in place for future project infrastructure on the gas grid networks along the new dual carriageway?
There's ducting alongside the verge, but no allowance for gas networks.
Yeah, yeah.
So there's allowance for future comms cables.
Yeah.
Yeah, there's a very, I suppose, very detailed ducting along the whole scheme. I think it's 6 on each side, 6 ducts, 6 free ducts on each side.
Yeah. Okay. Just quick, any potential difficulties? Is Paul O'Rourke asking the question in relation to backfilling the borough pits? Like, are you likely to suffer from settlement or, drainage issues in future?
They'll be assessed as they go, so there'll be an allowance made for settlement of these borough pits, and they'll be monitored over a period of time.
Yeah. Okay. Just a question in relation to passively safe columns. I don't know if they're talking about lighting columns or sign supports, but I don't know. Sean.
Yeah, plenty of passively safe signs. We sought to reduce the number of passively safe lighting columns by moving the lighting columns outside of the clear zone.
Yep.
Typically.
Okay, thank you.
There's a significant difference in cost between passively safe and not passively safe.
Okay. Hubert Henry's just asking again, scheme completion date. I think it was mentioned a couple of times.
Yeah, so that's October 2021 at the moment.
Yeah. Okay.
Substantial completion date.
Yeah. Bernard is asking a question, who's responsible for the maintenance of timber fences in the long term?
Somebody's looking for
that depends.
Inquiries to Sligo County Council.
That depends on whether it's along the national road or the local road. Along the national road, the local authority is responsible, and any local road fencing, it's the actual landowner themselves.
Yep. Alex is asking who was responsible for retaining all the landowner agreements. So presumably the Sligo County Council is part of the planning phase.
Yeah, they're all stored in Sligo County Council's filing system. Yeah.
I think we covered this already. Measures to discourage illegal parking along the scheme, particularly the offline cycleway being accessible. I think, Sean, you show that you've pushed the cycleway back in off the road, so it's probably not very accessible at all.
It's a lot more inaccessible now than for traffic, that is, than it would have been previously.
Delegate question here. Kate is asking. She's complimenting you on an excellent presentation. She's living locally. She's got a great insight. She's just asking, will the project go over cost the original budget?
We're certainly hoping that it won't go over cost.
Yeah. Okay, very good. Brendan is asking, were other earthwork solutions considered at the southern tie-in where the vertical drains were utilised?
Yeah, so certainly dig and replace was considered as an option, but the depth of the soft was just too great to allow for that. A piled embankment solution, I suppose, technically you could use, but it is be much more expensive.
Okay.
Solution require concrete and all those bad things.
Yeah. Okay, I think Kieran is asking the same question again, just about consolidation in the borough pits, but I think we've kind of addressed that. Breen is asking, great presentation. He's basically asking with regard to the barrier, any difficulties in achieving compliance with testing requirements of VRS posts where improvements to ground conditions are required? You haven't probably got into installing barrier in the median anyway yet.
Not in the median. Verge in the mainline barrier has commenced. I suppose all our verges are compacted as they're backfilled to eliminate concrete footings. But each barrier run is tested by motorway care as works progress, we'll say.
Yeah, and I presume the testing is in relation to the specification at the time that the contract was signed, as opposed to the brand new specification that's only out this year. Okay. Yeah, Marie Castley is offering to paint fences for people. That's great. Thanks, Marie. Paul Kassan, thanks for the presentation. Would you please confirm the eventual depth of soil where pile embankments were designed out? Did stability of the excavations require any additional measures?
That might be more for you, but I don't recall the actual depth. I know that vertical drains were kept on the table as an option through some of these areas until we really got into the ground and you know, kind of understood. You know, it was very closely supervised on site, I'd say, is the it was the main mitigation measure applied. Obviously, you cut your slopes to suit as well, but I don't know if that was anything else.
No, I suppose, look, the peat depths would have ranged, as I mentioned earlier, like from 2 to 8 meters, like, you know, so it would have been a full excavate and replace of potentially 8 meters, a worst case scenario.
Yep. Okay, we'll keep going. David Cleary just complimenting you again on your presentation, just asking, was the original program, was there any delays, and what were they, if any? I presume COVID might be one potential.
COVID was the main delay, really, 6 to 7 weeks. So the original substantial completion date was July 21. It's now moved to October, and it's really down to COVID. 7 weeks closure period.
Okay, very good. Donald Gilroy is local chair of the SPC2 Environment and Infrastructure Group, so he's just saying thanks to everyone involved and looking forward to seeing the project when it's finished. Complimenting on a drone, as if COVID, sorry, that was just, will Brexit be impacting the finishing of the works? As if COVID wasn't enough.
I don't, well, I'll leave that to you. I don't think there'll be any difficulty.
No, I don't think so. Not from our point of view anyway.
Okay, Philip Newell is asking, can you confirm how the central reserve is drained? Well, I suppose we don't really have a central reserve in the, it's just paved right across. Yeah,
the pavement's continuous across, so water will flow from one side to the other.
Okay, and one last question then, great work by all. Were the longitudinal swales with the check dams constructed in place of attenuation systems specified at specimen, or did you utilize dead space just to reduce the attenuation at the ponds?
Well, the dead space isn't quite right. The space would have always been taken up by some sort of ditch or swale to collect embankment runoff. So they utilised that space in certain instances that were widened out. Yep. But a combination, I guess, that, you know, in some places they completely replaced classic oval shaped ponds, albeit, I mean, they are a pond just in a line, let's say.
Yep.
But a bit of both.
Okay. Right, folks, listen, that's great. Look, thanks to everyone for their questions, and that concludes our Q&A. So just, I suppose, to finish, just on behalf of the Northwest region, I'd say a very big thank you once again to our speakers and indeed their employers, to Bernard Scott and Sligo County Council, to Brian Snow and Roadbridge, to Sean Fitzsimons and Clandillon Civil Consulting, for all your time and your effort putting together this excellent presentation. We know how busy you are delivering the construction of the scheme, so we're hugely appreciative to you for giving up your time to prepare and deliver tonight's presentation. It's hugely appreciated. We have small gifts that'll be in the post to you as just a small token of our appreciation for your time and effort. Before we finish up tonight, I just want to say a few quick thank yous. Thanks to my own committee, the Northwest Region, for their assistance in organising the talk. Thanks to Emer, Bernard and Matthew in Sligo County Council for facilitating and helping to arrange everything. Thanks to Carol and all in the Roads and Transportation Society for co-hosting the evening with us. Thanks also to Maureen in Engineers Ireland HQ, who's busy in the background there managing the Zoom platform and for advertising the event and doing all the background for us. Thanks to you, all the attendees. Thanks for joining us this evening and for attending. Sorry, we ran over a little bit, but it was there's a lot to listen to and a lot of very good questions there. And I think the measure of the questions reflected the interest in the scheme, which I think is excellent. We had over 232 people tuned in this evening, which is a brilliant number any night of the week. So thank you very much again. And don't forget to take off your steel toe boots now before you go back downstairs to rejoin your evening with your family. So if anyone wants to learn any more about the scheme, about the project, you can check out the project website. It's at n4realignment.ie. So once again, thanks again to our speakers, and thanks to yourselves, and thank you and good night.